Hey, so my name's Tyler. I'm a grad student in the University of Washington Atmospheric Science Department, and I'm out here today as part of our outreach team. And we're at a sort of Ask the Scientist climate science on tap event. So people are out just hopefully learning things about climate science. So this is basically an ocean acidification experiment. So it's sort of one way to help people try to visualize what is ocean acidification and how it happens. So in this little demo, basically we have a glass that's just water. We've added some dye to it. The dye is just pH indicator. So it basically tells you if the water is more or less acidic, the water will change color. So one thing we can do, and this is what happens out in the ocean right now too, is if you have carbon dioxide and it gets into water, a reaction takes place and it actually creates acid, and that makes water more acidic. So when we add carbon dioxide to this water, which we can do by just exhaling, because we exhale carbon dioxide, we'll see what happens to the color. So he is just exhaling, blowing into the water, and it started out as red. And now we can see it changing color as that carbon dioxide that he put into the water is reacting with the water and making it more acidic. So now we can see it's like pretty yellow. So what's happened is that all that carbon dioxide he put in has reacted with the water, and we now have pretty acidic water. And the same thing happens out in the ocean. All the carbon dioxide we pump into the atmosphere goes into the ocean and slowly turns the ocean more acidic. So if I'm a fish, or especially if I'm an oyster or a clam or something with a shell, if water gets more acidic, it basically could mean my shell dissolves. So it'd be like if all of a sudden my home just started dissolving around me. And maybe you don't eat oysters or mussels or clams, but a lot of other animals in the ocean do eat those things, and we're all on the same earth together. So it's certainly not great if we create an acidic ocean that some animals can't live in. One of the big things with ocean acidification is that there's a lot of unknowns. Like, we don't know that much about the ocean, and we know that ocean acidification is bad for some species because we do tests in labs and we see like, oh, when it gets more acidic, it's bad for this species. But in the ocean, it's really complex, right? Like, if one species, if one fish or one clam or one like phytoplankton goes away, that has a whole cascade of other effects sort of up the food chain to other animals. So even if it's maybe not going to kill all the tuna fish that you love directly, it certainly might be hurting their food source. And so it's something that's like tough to see on a day-to-day process. You don't see the ocean getting more acidic, but there are certainly lots of little critters that might be eaten by the critters that you do care about that are going to be negatively affected by it. I think ocean acidification is a tough one because really the best way to improve things is to have less carbon dioxide that's emitted into the atmosphere, which is a big societal issue for sure. In the Northwest, there's a lot of research being done about ocean acidification because it affects various different oyster farms, which are big in the Northwest. But really, I mean, I think if you are concerned because you love oysters, or you're concerned because you're a citizen of the earth about ocean acidification, I mean, I think the best thing you can do is just be cognizant of how your actions are emitting carbon dioxide, and just pay attention to things.